In this video, we're going to be looking at applications of quadratic equations. Our first problem, John owns a hot dog stand, and he has found that his profit is given by the following equation, where X is the number of hot dogs sold. How many hot dogs must he sell to earn the most profit? First thing I want to do is to make a quick sketch. I have a parabola that's opening down, and I know it's opening down because of the leading coefficient here being negative. I could also put this in my calculator and graph it and see the shape of the parabola. My horizontal axis, X, represents the number of hot dogs, and my vertical axis is the profit. So this point, XY, my vertex XY, gives me the number of hot dogs that I have to sell to earn the most profit. So X is the number of hot dogs to earn the most profit. The X coordinate of the vertex is negative B over 2A. So negative 52 divided by 2 times negative 1, and that's 26. My next problem is very similar to the problem that I just did. I still have John owning a hot dog stand, and I have an equation that represents the relationship between profit and number of hot dogs sold. But the question this time is different. The question that I'm asked in this problem is, what is the most he can earn? So I'm still going to use this same sketch that I used in the problem above here. So I still have my X-axis being the number of hot dogs and my Y-axis being profit. But in this problem, I want to find the Y-coordinate of the vertex. I want to know how much money is the most he can earn. I'm still going to need to start with negative B over 2A to find the X-coordinate of the vertex. And then I'm going to plug that number back into my formula to find the Y-coordinate. The X-coordinate is 12. Once I find that, I plug that back into my formula to find the Y-coordinate, and that's 212. So the most he can earn is $212. I want to say something else about these two particular problems with John and his hot dog stand. Now, normally I like to tell you that you need to make sure that your answer is reasonable, that it makes sense in the real world. And I don't think that these problems always do. Sometimes you will have John needing to sell like 8 hot dogs to earn the most. And that's kind of unreasonable that John's going to get up in the morning, get dressed, and get his little hot dog cart and go out to work just to sell 8 hot dogs. So with this particular problem, I wouldn't worry too much about my answer being reasonable, but do be sure that you pay attention to which problem you're asked to find. Are you asked to find the X-coordinate of the vertex or the Y-coordinate of the vertex? In this problem, I'm asked to find a pair of numbers whose sum is 62 and whose product is a maximum. The first thing I'm going to do is to define my variable. X is going to be my first number. Now, I know that the sum of the two numbers is 62. Remember, sum is the answer to an addition problem. That means if I add the two numbers together, I'm going to get 62. So my second number has to be 62 minus X. Now, in my problem, I'm also told that the product needs to be a maximum. So the product is the answer to a multiplication problem. So that means when I multiply these two numbers together, I want to have a maximum. Okay, so you can see here that I have my equation written out, multiplying my two numbers together. It's going to give me my product. And I also have a sketch of my parabola, and my vertex is labeled XY. The X-coordinate represents the first number, and my Y-coordinate represents the product. Now I'm going to come back over here to my equation, and I am going to distribute this X. Then I'm going to rewrite this equation so it will be in standard form. I want my x squared term first. And from here, I'm going to use negative b over 2a. So my first number is 31. And my second number is going to be 62 minus 31, which is also 31. A coffee shop is planning to construct a rectangular parking lot on land that is bordered on one side by a highway. The coffee shop has 120 feet of fencing that is to be used to fence off the other 3 sides. Determine the maximum area that can be enclosed and the dimensions of the parking lot. So the first thing I'm going to do is to make a sketch. Okay, so I have my parking lot sketched out and I've labeled the width W. I've also indicated the side that is bordered by the highway. The next thing I want to do is to figure out an expression for the length of the parking lot. Now remember, I'm starting off with 120 feet of fencing. I used W feet here, I've used W feet here, so the amount of fencing that's left is 120 minus 2W. I also know that the area of a rectangle is length times width, and I want to maximize that area. So I'm going to substitute in 120 minus 2W for the length. I have W for the width. I'm going to distribute. I'm going to rewrite this to where the squared term is first. Now my equation is in terms of W and A, but what I need to be thinking, this is my little thinking bubble, I need to be thinking of this as y equals negative 2x squared plus 120x. So you can see I've sketched out a parabola here. Width is on my horizontal axis, area is my vertical axis, and I'm looking for the vertex to give me the width that would give me the maximum area. So again, I'm going to start off with negative b over 2a. So the width is going to be 30. Then I need to find the length. So the length is going to be 60 feet. To find the maximum area, I multiplied length times width. And I get 1,800 square feet. Now there is another way that I could have found the area, the maximum area, and that is to find f of 30, because I know 30 is the width that would give me the maximum area. So I could put 30 back in place of x, and that would give me 1,800 square feet as well. If an object is thrown upward with an initial velocity of 192 feet per second, then its height after t seconds is given by the following equation. H equals 192t minus 32t squared. Part A, find the maximum height obtained by the object. Part B, find the number of seconds it takes the object to hit the ground. Now, the first thing I did was to rewrite my equation in standard form up here at the top. And then I found the x-coordinate of the vertex. And remember that the x-coordinate, in this case, it's a variable t, is time. So this tells me that it's going to take 3 seconds to reach the maximum height. So once I find this 3 seconds, I'm not done. I now need to find f of 3. Put 3 back into my equation in place of the t, and I get 288 feet. One thing I want to point out about this problem is that you're not asked to find how many seconds it takes to reach the maximum height, but you still have to do this step in order to answer the final question. Part B is asking us to find the number of seconds it takes to hit the ground. Well, I know that my equation is a relationship between t for time and h for height. Well, when my object hits the ground, the height is 0. So this is the equation that I need to solve. And there's a couple of things that you can do. One thing that you can do to solve this equation is to use the quadratic formula. You would first of all need to rewrite this to where the squared term is first, and then use the quadratic formula where A is -32, B is 192, and C is 0. But what I'm going to do here is I'm going to factor out a greatest common factor, and I can use my calculator to see if 192 is divisible by 32, and it is. So I factored out my greatest common factor of -32 times t. And now I'm going to set each of my factors equal to 0. So when I solve, I get t to be 0 or t to be 6. Now, t sub 0 means times 0. So that means that at the beginning of this problem, the object is launched from the ground. And then in 6 seconds, it's going to come back and hit the ground. So my answer is 6 seconds. A toy rocket is shot vertically into the air from a launching pad 4 feet above the ground with an initial velocity of 160 feet per second. The height, h, in feet of the rocket above the ground at t seconds after launch is given by the following function. How long will it take for the rocket to reach its maximum height, and what is the maximum height? Okay, part A, how long will it take for the rocket to reach its maximum height? That's going to be the x-coordinate on my vertex. So that's going to be 5 seconds. The second part is what is the maximum height? I'm going to have to put 5 seconds back into my formula in place of the t, and I get 404 feet. A person has a taco stand. He has found that his daily costs are approximated by the given function, where C of X is the cost in dollars to sell X units of tacos. Find the number of units of tacos he would sell to minimize his cost. What is the minimum cost? So in this problem, my picture is going to look different. I have a parabola with a positive leading coefficient. So my parabola opens up. My horizontal axis is the number of tacos, and my vertical axis is cost. And I am looking for the minimum cost. So first of all, I need to know the number of tacos that would give me the minimum cost. So I'm going to do negative b over 2a. So I get 15 tacos. And then I put 15 back into my equation. So I'm going to get $290. And there's a couple of things that I want to mention overall about the application problems in this chapter. First of all, do not get problems confused, like where you are trying to find the solutions or your x-intercepts. Don't get those type of problems confused with when you're trying to determine a vertex or the x or y coordinate of the vertex. Also, be sure that you utilize your graphing calculator. The graph is going to help you determine like whether you have a maximum or a minimum. And if you look at the table that's associated with the graphing calculator, look at your table in your calculator, and you can sometimes find the vertex from there. You're not always going to be able to, because sometimes that vertex is a fraction. But that's usually going to give you a good idea of whether you're on the right track or not. If you ever get stumped on these word problems, you need to do one of two things. Put your equation into the calculator and graph it, and look at the graph or the table. Or the second thing is do negative b over 2a. Now, negative b over 2a may not be your answer, but it may be the first step in getting your answer. You're going to get negative b over 2a, and then you may need to go back and put that number into your function to figure out your final answer. One thing I want to point out about using the formula negative b over 2a is you need to be sure that you know how to put something like this into your calculator. Because if you put it in the calculator incorrectly, you're going to get the wrong answer. So even though it looks like a very simple problem, and you may look at it and you think, oh, I know how to do that, take the time to actually work through some of these and put them in the calculator to be sure you know how to put that into the calculator correctly.